Hey y'all, so for today's session, we're going to be really zoning in on subtraction. Thinking back to second grade when our students use those number bonds and have to isolate and break apart the parts of a subtraction sentence. So just what is the whole? What is the given part that we're taking away? What is the missing part? And how then they can use our place value charts or those manipulative representations such as the place value disk. And how those same processes and those same steps can be translated to the written form, or what we call the standard algorithm. So during today's session, I'm going to actually model a 2-digit by 2-digit subtraction problem as if y'all are my scholars. So as I'm modeling the problem, I want you to engage as if you are a scholar. So answering my questions, having that back and forth, but really keep on that teacher hat of what are the steps and the processes that she's following to ensure that her scholars are successful. What are those little nuances and those little things that are going to ensure that our students have this concrete understanding of what subtraction actually is. Because if we can start as young as our K2 babies, making sure that they know and understand the processes of these math operations, then when they get older into say 5th grade and are having to do subtraction with decimals, that concrete realization of what place value is and how we unbundle and how we can use those visual representations for the standard algorithm will ensure that they are set up for success and that their learning actually transcends. It doesn't stay stuck in just one grade and then forgotten. So after I model, I'm going to then release you to try a couple on your own. Now, I know as adults in a PD session, especially as a math PD session, as soon as you're released to do any math on your own, you're going to skip ahead to whatever method you find the easiest, which is probably going to be the standard algorithm. But I would really push you to solve the math the same way that you would expect your scholars, and you would push your scholars to solve the math. Because if you use the same models, the same strategies, and the same processes that you would ask your students to use, then you're going to be better prepared for when it's live in the classroom. You're going to be better prepared to find those misconceptions, to find those errors, and be able to fix them in the moment and be proactive versus waiting until you get that assessment and saying, oh wait, they did this, or oh wait, they did that. After you do a couple on your own, then we'll come back together and debrief to make sure that this learning is just as concrete for you as it will be for your students. So you're able to take this back into your classroom and continue that learning continuum. Are there any questions or concerns before we start? Okay, great. So you'll pull out your participant handout. We're going to start with that first problem of 31 minus 18. Okay, let's begin. Okay, scholars, today we are going to talk about subtraction. So if you look here, I have a 2-digit by 2-digit subtraction problem written in vertical written form. So, let's say this with me. 31 minus 18.
31 minus 18.
Great. So when I look at this, let's first see if we can break it apart and find what is my whole. What is the number that I'm actually subtracting from, class?
31.
Yes, exactly, that 31. So I'm going to draw a circle around it and make this magnifying glass. I'm going to zone in, almost like a detective, on that 31, because this is the number that I'm actually taking away from, right? This is my starting point. This whole number is the number that I can actually use to represent the subtraction sentence in a visual way on my place value chart. So let's think. How can I break apart this 31, my whole, into its units to be represented on my place value chart? How would I say 31 as unit form, class?
3 tens and 1 1.
Yes, 3 tens, 1, 2, 3, and 1 1. Nice job. So now I have my place value chart that mirrors my written form, and I'm able to start subtraction. And we know that when we're subtracting, we always start with our smallest place value, which is our what?
Our ones.
Yes, so let's look at my ones. I have 1 1 minus 8 1. Notice I started with that 1 1 because that's just in my magnifying glass, right? That's my whole, that's my starting point. Well, 1 1 minus 8 ones, can I do that math, class?
No.
No, I can't. I can't take 8 ones from 1 1. So what must I do, guys?
Unbundle.
Yes, unbundle. Let's be more specific though. Unbundle what?
Our tens.
Our tens, yes. So let's look at my tens. Am I unbundling all 3 of my tens?
No.
No. How many tens do I need to unbundle?
1.
Good. So I'm going to mark out one of these tens, and I'm going to draw an arrow, and I'm going to unbundle it by moving it over to my ones place. So let's think about this. 110 equals how many ones?
10.
Yes, so let's draw my 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now let's get our written form to mirror what we see in our place value chart. I no longer have 3 10s. How many 10s do I have?
2.
Great, so let's mark out my 3 and change that to a 2. I no longer have 1 1. How many 1s do I have?
11.
Exactly. Now let's see if I can do my subtraction. So starting with my ones place, I have 11 ones minus 8 ones. Let's do that on our place value chart. Count with me, class. Ready?
1, 2, 3, 4, 5, 6, 7, 8.
Nice. So I've taken away my 8 ones from my 11 ones, and how many am I left with?
3.
Great. So I'm going to put that in my ones column. Now I have 2 10s minus 1 10. How many 10s am I left with?
1.
1. So I get 13. So in my written form, I have 13. Let's check to make sure our place value chart has the same number. So how many 10s do I have in my place value chart?
1.
Good. And how many 1s do I have in my ones chart?
3.
3. Notice, scholars, that the work that I did on my place value chart with my unbundling and my subtraction is the exact same work that's mirrored here in my written form. So I got the same answer with both methods. Great job. Okay, cut. So now we're going to release y'all to try a couple on your own. So again, remember, I know it's so easy to just want to go straight into that standard algorithm, but I would really push you to use the same strategies and model that you saw me use when I was doing 31 minus 18. You'll have 5 minutes to do these 2 problems on your own, and then we'll come back together and debrief. Okay, your 5 minutes are up, so we're going to bring it back in 3, bring it back in 2, and 1. Nice work. So as I was kind of looking around and seeing what you guys were working on, almost every single one of you used your place value chart and made sure that the work within your place value chart mirrored what you had in your written form. But there was about half of you that skipped one little tiny nuance when you were working on specifically number 2. So let's look at problem number 2. 77 minus 58. About half of you forgot to do this for number 2. Well, that's a little step, right? Why would it be so important, and why would it be such a misstep to forget to use our magnifying strategy with the 77? What is so important about the 77? Why are we trying to get our students to zone in on the 77?
It's our whole.
Yeah, it's our whole. And why is our whole so important in terms of subtraction? What do we use our whole for? Think about how we take our whole and we break it apart into its units, and we use it when we're doing what?
Our place value chart.
Yes, exactly, our place value chart. So we're wanting to ensure that our students zone in on that whole number because that's the actual number that we use in our place value chart. But even when we don't have a place value chart, that is the number that we're doing our unbundling with, right? That's the number that we're actually taking away from. Because if we don't ensure that our students are zoned in on that's the starting point, that's the whole, it would be so easy for them to make this mistake. If you saw this on an exit ticket in your class, what mistake would this student have made?
They took 7 away from 8.
Right. But if I'm a student, you've told me a gazillion times that I take the smaller number from the larger number. That's what I did. And you also have told me a gazillion times that I always start on my ones place. Well, that's what I did. So this little step of making our students really zone in and encouraging them to use this idea of a magnifying glass, that starting point, that whole that we're taking away from, as small as it might seem, it can help prevent them from making an error like this. Awesome work, guys. Okay, we're going to continue with this and see how we can translate this into our next lesson. Thanks.